How are you doing?
I'm doing fine. I'm doing fine.
Can we start the interview now?
Yes, that's fine.
Ok. Olá, eu sou o professor Luciano Daniel e hoje estou aqui com a professora Marta Molinas, que leciona em uma universidade em Trondheim, na Noruega, e é uma grande pesquisadora aí da área de eletrônica de potência no cenário internacional. Hi, Marta. I am grateful and honored that you accept my invitation.
Thank you very much for inviting me. I will be happy to answer the questions that you have for me.
Marta Molinas received the Doctor of Engineering degree from the Tokyo Institute of Technology, Tokyo, Japan, in 2000. She was a guest researcher with the University of Padova, Italy, during 1998. From 2008 to 2014, she has been professor at the Department of Electric Power Engineering at Norwegian University of Science and Technology, and since 2014, professor at the Department of Engineering Cybernetics, NTNU. Her research interests include stability of power electronic systems, harmonic and non-stationary signals from the human and the machine. She is editor for the IEEE Journal of Emerging and Selected Topics in Power Electronics and IEEE Transactional Energy Conversion, assistant editor for the IEEE Power Electronics Society and the IEEE Transaction on Industrial Electronics. Molinas, tell me about the types of research you have developed and those you are currently developing at the NTNU involving power electronics, please.
Since I arrived in Norway in 2004 until the end of 2013, I was working with application of power electronics to the interface of renewable energy, such as wind, solar power, wave power. So I was working mostly on the control of the power electronics interfaces to introduce this new type of energy in the electrical grid. And at the end of that period, I started working with the stability of power electronics because it became an issue if a lot of wind, a lot of solar power or wave power was penetrating the electrical grid. And then I started looking at the stability issues, starting with one converter and going through more parallel connected converters until to a large number of converters. The stability, what I'm still concerned today is the stability of an electrical power system in which there is a dominating number of power electronics components. And that's quite a new thing because the systems in the past were not like that. This is a new type of system we are creating today.
And how did you become interested in working with electroencephalography, EEG signals?
Yes, I moved to a new department inside the university in 2014, the Department of Engineering Cybernetics, and as the name indicates, they work a lot on control application applied to many different types of systems, like process engineering, chemical engineering, maritime systems, and they've been working less in electrical grid applications. And I started working with them on that, but driven by my curiosity as a scientist, I was always interested in the electrical engineering inside human beings. And the only way I could very easily start with that was by analyzing the electrical signals that are more easy to obtain from human from human beings non-invasively, which is the electroencephalography. So it is mostly driven by my curiosity and to align a bit more with the activities that were more of interest in the new department where I moved. So in the electrical voltage samples that we can acquire from the human scalp are having exactly the same properties as any other electrical signal that we are used to in electrical engineering, with the adding aspects of complexity. So it actually became a much more challenging field from the point of view of signal analysis of electrical signals. And I am just starting with that because this started in 2014, so it's barely, say, 6 years now I've been working it, and it is slowly moving, because when we have to establish a solid research in a new field, it can take at least a decade. For me, in power electronics, I started basically in 2004, and in 2014, I moved to another field. So it was exactly 10 years of work to be able to establish some solid research, I would say.
Well, what are the programming languages for prototyping? For example, MATLAB, Python, Julia, Octave, Scilab, I don't know, that you team and you use, and why?
Yeah. For many years, for all the period that I was working with power electronics, we actually were more inclined to use MATLAB. And most of the work done until then by my students was based on MATLAB or PSCAD. And the reason for using that was simply of sharing with other colleagues or other students that were in another university, and they were using MATLAB. When I moved to the new department since 2014, I decided to move into Python, and we started changing all our codes, all our models into Python, especially when I'm working with Brain, because the community of Brain is much larger community than power electronics. And you cannot limit yourself to MATLAB. In fact, MATLAB is very rarely used. In this community, people develop their own softwares, and there are other platforms that are being used. But the main reason for me to change was to be able to share with anyone in the world and to discuss with anyone in the world, independent of commercial software. So it is more difficult, slow the change, but my students are passing everything they have in MATLAB. They are translating it into Python. Some people will use Julia because it's maybe a more, say, friendly interface for some things. But we are also new into all those platforms, so we simply use Python at the moment, programming everything from anew. Yes,
It's true. Do you have some interest in artificial intelligence or big data? Anyway,
activities, research activities, you mean, or
research activities?
Yeah, I think this is kind of like the topic, the boom topic of the moment. Everybody is talking about it. Maybe not everyone is understanding what exactly it means, but everywhere this artificial intelligence or machine learning is coming as the most important topic to put your research in line with. And of course, we are working on that too. When we work with brain signals and with such a complex systems like the brain or the human system, then modeling is very difficult. Although I'm very much inclined to keep modeling as my most solid platform. But when a system is so complex, then you benefit from having some artificial intelligence or machine learning techniques applied to it to elucidate what is happening, but you will not know why it's happening. So we keep always the two ways of analyzing a system, and sometimes we hybridize, we combine them, the model-based and, say, data or driven or signal-based, to try to answer both questions, what is happening and why this is happening. So for me, it's also a learning, it's much a learning period and a learning process now to use artificial intelligence. I don't have any background on that. So I'm studying all these topics, new topics, to be able to apply and see what can be extracted from them in our research.
Okay. Norway is very cold, very, very cold. But now is summer.
In Norway, summer is kind of ending the summer and starting the spring soon. Yeah. But it's not really a summer.
Do you live in Trondheim city? Trondheim city.
Trondheim. Yes. Yes.
Okay. Professor Marta, thank you very much for this interview, and I wish you success in your academic activities and your life in general. I hope that you can make your dreams come true and that you continue to be a happy person full of energy.
Thank you very much. And same wishes to you also. And I hope we can keep in touch and perhaps collaborate if you are interested in biosignals.
Bye and hugs, Marta.
Bye, bye. Bye, bye.